Introduce myself. My name is David Sidrane, and I own a consulting company called NSCDG. I started working in NuttX, I think, in 2011, and in 2014 I was contacted by Lorenz Mayer, who's the founder of PX4, to help bring PX4 current with current mainline NuttX. So there's a lot of history behind PX4, and one of the things that we can look at is the original drone that was built. It was designed and built by Lorenz at ETH in Zurich, and it actually has an IMU that's 3 separate axes, 3 individual sensors on the drone. And they began the project in 2008. By 2009, they had this piece of hardware. And 10 years later, we just had a meeting in Zurich with 200 PX4 developers. So the project grew and is probably one of the most active open source projects on GitHub for drones, at least. So interestingly enough, is a quote from him about a decade ago: little did he know that a student project would create such a thing and become a de facto standard in the drone industry. So information is available at PX4.io, and GitHub is PX4. So when we talk about PixHawk, it's kind of confusing because there's PX4 and PixHawk. PX4 is the software stack, and PixHawk is the reference for the actual autopilot hardware. So you'll also find a pixhawk.org and also PixHawk on GitHub. Those are hardware reference designs. So I was fortunate enough, Julian, when he came to the show, brought one of the original PixHawk FMU V1. So let me describe what FMU is, Flight Management Unit. And V1 was the first version of the architecture. That was, I guess, you know what year this one was done? 2012. 2012. So this was the first FMU, and it was 2 boards. One of them is what's fondly known as the PX4.io board, and the other one is the FMU. This is the I.O., and this is the flight management board. It was a 2-board set. It was based on a STM32 F407 and an F100. So as time passed, we went to FMU V2, which was a 429, and the same F100. Shortly after that, I guess, during the development of a product called Solo for 3DR, FMU V2 was established, and that's this cube design that you see in the middle. And then we progressed to doing a racer design, which is FMU V4, also with the F427 and no I.O. It's a smaller footprint, and it's built just for being on a small racing drone. As the system developed, we did a more compatible version with what V2 was, but on a 469. So the capabilities of the 469 are more memory, and it has a lot of IP blocks that are actually in newer processors from ST. And over a period of time, the hardware developed and evolved. As you see across the bottom here, there was a lot of more versions of the hardware built. So what is an open hardware reference standard? And one of the reasons that I haven't been as active on NuttX lately is because I've been managing the pinouts, the block diagrams, and schematics for the future designs, the current designs and future designs. So I haven't had as much time to contribute, except when we actually get hardware, and then I'm doing submissions to bring us up to running on a new processor. So, you know, what basically this is, and you can visit this when the slides get published. It's probably easier to go and look at this, but it'll take you to the actual design documents for the hardware. Some of the designs are open sourced at the level of providing you a schematic. Some of them are not. We'll talk about that in a little bit. So I guess the question is, what happens when you create an open hardware reference standard? And this is what happens. I don't know how many manufacturers there are, it's hard to tell, but a lot of hardware got built very quickly, and PX4 supports all of the hardware. So we have a binary compatibility at the FMUV level of software on hardware. So FMUV2 software runs on, actually FMUV2 and V3 run on the F429. FMUV5 runs on the F7. The future, fancy syntax up at the top there, is FMUV6, FMUV5, V5X, V6, and V6X. And the difference between the V5 standard and the X series, or the 6 standard and the X series, is higher reliability. So, you know, over time, what we found is there's some reliability issues with sensors. And you can have single access failures on a MEMS sensor. And you need to be able to detect that, and you need to be able to do something about it. And you can't really have 2 sets of sensors because you can't vote which one's right. Or when you have 3 sets of sensors, you know what the correct answer is. So the new architectures, the X architectures, have triple redundancy. We've been working with different manufacturers. One of them, the original V5 is a company called Holy Bro, and they produced the FMU V5, which they call a PX4. This gets confusing. And a PX4 was the same dual processor architecture, but it's an F7 and an F100. And then they have what they call their Mini, which is more akin for a racing drone, and it has only the F7 on it. And recently, and just actually I think yesterday, CUAV, which is I'm going to pass this around because it's really nice. A Chinese manufacturer just released their new versions of the FMU V5, and these were the prototypes for validation. So let me ask a question here. How many people were familiar with PX4? Okay, a good number of people. So we're currently prototyping FMU V5X. That's the hardware that actually was built the beginning of the week before I left, and they're just doing final assembly, and we'll be bringing up the boards when I return. All of these products run NuttX. And the reasons we chose NuttX, like everybody else has said in the room, is the licensing, the POSIX interfaces. It's a real-time OS, very important. For me, I look at it also as the degree of scalability, because we run on an F1 with very little memory, and we run on an F7 with a lot of memory and a lot of horsepower. And being able to adapt and scale it makes it extremely versatile, and I think that's really an important thing. And then really the code quality and conformity is really important, because it's quality. You can look at the code, it's understandable, it's readable, and the quality just is evident in what you're seeing, and that I think is really important. So how is PX4 built on NuttX? PX4 builds NuttX differently than mainline NuttX. We use CMake to drive the make system, and we build an out-of-tree build for each platform. So when you see all the V-series, we have to do multiple builds for each one of the V-series builds. We have to do 2 NuttX builds for a configuration that has 2 processors on it. And what we do is we do an out-of-tree build, and we used to use make export, where we would export, we basically copy things into a directory and build there. and then run the export and take the library back and link to it. And then we started realizing that we could get better optimization by using CMake and building it to libraries that were CMake projects. So we actually build the individual libraries of NuttX and we link to them. You know, I mean, people are kind of familiar with what CMake is, but I think the key thing about it is that it runs everywhere. And there's no platform, there's no special code in the make files, or in the CMake files that are platform dependent. It just understands the environment and it builds. We can build on Windows, we can build on Linux. I don't know about BSD, but I'm sure it would work there as well. It's really cool. The other thing that we do is we use CC Cache, which is a, is it anybody familiar with CC Cache? So, you know, what the, I guess the metric is that the compilation stage when you're pre-processing is the longest pole in the tent, effectively. And so what CC Cache does is it builds through the preprocessor, and it hashes those. And if it gets the same hash on a H file, it doesn't have to recompile it to that level, and so it optimizes the build, and it's quite fast. And then we also use Ninja Build, which is a build system that's focused on speed. And the question is, why do we do all this? We do it because every branch, every pull request is tested against master before it comes in, and we have to build, I don't know, 35 platforms, and we need to do it quickly. So that's the motivation behind it. What it looks like is, it looks like make to build a target. You know, it's make PX4 FMU underscore v5 or NXP FMU RT 1062 v1, and those are how the targets are built. Tools are familiar but a little bit different. We run old config and menu config directly from our level, and the tools react exactly as you see in NuttX, but single command line. And the thing here is, it's kind of hidden under the hood, is we build an NSH configuration. So we have one config file, so we don't have to have the second parameter on the command line, because it's kind of known ahead of time. We build what we can in parallel. We drive the def config process just through the make interface in NuttX to get to the .config. And we dynamically add the built-ins that we want to add to the commands by some, I guess it's Python magic that gets done, and creates the set of files that are then compiled just like the built-ins are compiled in a normal NuttX build. And then we used provided magic, which took me a while to understand when it came in. And we call every board that we build PX4, and we just pass it the NuttX config directory. The PX4 repository is organized differently. So I guess let me emphasize a couple of points. We split the source and the NuttX configurations into two pieces. So you can see there's a directory there, NuttX config. Underneath that, you would find the def config and the scripts that are normally found in NuttX. The source is brought up here. The init directory is a little misleading because it's actually the RC init files. It's not any initialization code per se, executable initialization code. It's the actual script, NSH scripts. The source directory contains what you typically see in NuttX as the source directory containing the board level files. But we don't build that library inside of NuttX. We build it inside of PX4. We build an empty library and we link to it. And what that does is you can make really rapid board changes and not have to recompile NuttX. So if you're working in your board configuration files, if you change the def config, you have to recompile NuttX, of course. But if you're changing local code for board startup, you don't have to recompile. So it speeds the development process up. You know, and the default .cmake is basically all of the modules that we want built in PX4. So PX4 is divided up into modules and drivers. Modules are typically NuttX applications. Drivers are our version of drivers, which are kind of different than NuttX's drivers, and I'll talk about that in a little bit. So let's see if this works. So it's probably really hard to see, and I don't know if I can zoom this in or not, but
hit the button.
Let's see how we do. So maybe we're starting it again. So the command at the top, which you can't see, is a clean and a build. And this is building, I guess there's 5 million lines of code in PX4 and maybe 1 million lines in NuttX. We're not building all of them, obviously, but that's how long it takes. And that's on a desktop. So it's, you know, like, okay, now to be fair, that's not the first build that was done on this machine. CC Cache has all the information on it. It's already cached it. And because of the CMake optimization and Ninja build, it blazes through the build and you get really quick build times. Oh, I guess I'm running it again whether I want to or not. But now you can see it. So the first set of steps are the NuttX, or the CMake configs, and these are actually the build steps. If you look, I think there's 1,200 of them.
Gotta count fast.
Yeah. So that's producing the ELF file, and then we package the ELF file wrap it with metadata that has the actual parameter information that is used to configure the drones, and that becomes a PX4 file. It's was it UU encoded file, or
is it JSON?
Or, yeah, some of it's JSON. I think the binary is there.
And that, yeah.
So let's see how I get out of here. Oh, that worked almost. Okay, so I was at the NuttX Developers Conference, and Scott Dixon, who works for Amazon in their drone projects, did a presentation about, you know, test how you fly, and I like the title, so I stole the same kind of concept here. But what's hard to see, and it was really hard to represent, is these are all parallel builds that are done when you do a PR or a commit, and it will build 35 complete builds of about 5 million lines of code in less than 11 minutes. So we have parallel builds. We lean very, very heavily on the CI tools that we use. We build PRs before as branches, so we use a branch methodology where pull requests come in as a branch of master. When the PR is, I guess there's 2 phases. The initial commits are built, and then every time the PR is updated, it'll be rebuilt again. So it prevents merging code that will break master. And we also run A-style checks to prevent merging code that does not conform to the coding standard. There's also a set of tools when you're at the command line, you can do make format, and it will fix the code to the coding standard automatically. So the first step is testing as you code. So this is actually 35 builds. This is kind of zoomed in of what that looks like. And it was, well, you can see the time, it's right here, 10 minutes and 50 some odd seconds. So then the next thing that's important to us is actually testing as you would fly. So Daniel Agar, who is maintainer of PX4, has in his office this cubicle. We built some specialized boards. I'm actually using one, so I can't hang it and show it in the air here, but so pass this around. This is the first generation of the board. The issue here is that, as with anything, you know, you started off with RS-232 connectors that were this wide, and they got this wide, and they became USB buses, and things evolved over time. During the life of PX4, the debugging interfaces had changed from an ARM 10-pin to what we call the drone code 6-pin. Then there was the misunderstanding of which connector was used as the drone code 6-pin, so there's another version of it, which is not a ClickMate, but a GH a JST-GH connector. So that board basically is the unification layer that takes all of the possible connectors that you could have on any of the drones, and it brings it out to a 20-pin J-Link interface and also the 10-pin J-Link interface. And what's in each one of these cubicles is a flight controller, one of those boards, an FTDI, and then there's a set of hubs that are sitting there behind a old computer that's running Linux. And it does these builds. So the code is actually being built in parallel in the cloud, but being run on the targets here locally. And as you can see, all of them are green, so they're passed. But the idea is that we have a set of tests that are built on the target, which is going to be ever growing because it's really important for long-term planning, certifications, etc., to have really complete test coverage. But if we break something in mainline, we see it here before anybody else sees it during the build process. So each PR that goes in is run through CI to get built and checked for, is the code broken? And then the main targets that we're running against are programmed here and run, and any failures are identified. And if you can't pass this, the code doesn't come into mainline. So we know that we have build test and run test. And you know, I think there's a lot of people doing this sort of thing. I mean, I've seen it done with Raspberry Pis, controlling off-board with different integrated build systems. This was our tool stream, so we used it, and it's become very effective for us. So we talked about how we build NuttX, and we looked at, is there a way to make this even faster? And we've been working on a complete CI for NuttX. This example here is building 20 builds, and it does it in 3 minutes and 38 seconds. It's hard to read all the different configurations, but they're STM configurations of varying type, NSH, NSH USB. I think there's some Ethernet ones. And what we have is between a 12 and 20 second build time for each board config that you would type, you know, make configure, or configure board, and then which config. And we would like to offer to put this into NuttX and support it as our contribution to NuttX. And you know, there's been a lot of heated discussions about CMake and CI, and I've said the bad words out loud, yes. But I think that when you actually can experience the value of it and you see how it works, it's like, okay, I understand the argument about spaces and tabs. I actually like spaces better, okay? But that's because it makes sense to me, and this makes sense to us. And we'd like to offer it to the community, and we'd like to support it. So that's something that Daniel and I have discussed, and we're willing to do and maintain it. And I think last night when we were drinking, Greg said to me, will you sign a contract for life? And I said yes, but I'm not sure if that was because we were both tired or because we had been drinking. So I have to reconfirm it when we're sober, but it's something we'd really like to do. So what we need to do this is we need to include a YAML file and CMake in upstream. We've looked at ways of doing it without that. We could do it in parallel, but it's not as efficient. So, you know, I'm opening my heart to, you know, looking at this and figuring out a way to do it. So, something to discuss. The other thing that we were talking about is that if you do a pull from NuttX to get apps and to get NuttX at the same time, there's no real, what I call a knot that ties the two together other than the release level when there's a release done. And we would like to see some mechanism, if it's maybe just one more repo that is just submodules, so you get a guaranteed consistent apps. Because if you look at, you know, you're doing a push and I'm doing a pull, and I get NuttX and then I go grab apps, I might get them out of sync. I might get the old apps in that time. So that's something that we need to look at. Differentiation of things are just kind of some cool things that we like to talk about. Beat he's a member of PX4 development team, did a DMessage program that's cool, and we needed it really badly because the way our system boots, everything comes to the console, which is great, but nobody connects a console in the field usually. So we want to be able to log all the console output, and what he did was he wrote a DMessage, which is basically an in-memory queue that you can run at any time that will then redump what happened during boot time. So we get basically almost from the exact time we boot, we have all the messages available.
So this is different from the DMessage that's built into the operating system?
Well, he did it as an application outside.
So DMessage is supported by NSH, and it works the same way as you described it, buffers in memory until you type DMessage.
I am not sure why he did it the way he did it at the time, but this was, what, about 3 months ago, 4 months ago, I think, is when it was there. And I'm not sure what the issue he had with what was there, but he couldn't get the output that he wanted.
Was that he couldn't get the output early enough?
I think that's what.
Because it might just be that the RAM log isn't brought up until later in the boot right now. But I see no reason why it couldn't be brought up earlier.
RAM log comes up pretty early.
Yeah, what we couldn't get from boot, so he did it. And it's pretty trivial where it's done. It's in our boot sequence. The other thing that that was done is what's called the HeartFault Log. So if you look in the STM32 architecture directories, you'll see something called BBSRAM. And what that is the battery backed up SRAM in the clock has 4K of memory. Well, when a drone crashes, both mechanically and software-wise, you need to know why. And the idea here is that when the heart fault occurs, we want to capture all the context, save it. We put it in battery backed up SRAM. When we're back rebooting and we're sane again, we check the SRAM for a heart fault log and we commit it to disk. And then it gets uploaded to the cloud in log files, and when you review a flight, you can actually see that you had a heart fault. And you can see the cause of the heart fault. So that's a kind of a neat application. We also have a version of TOP that's kind of cool. It gives you all the normal top process information and stack penetration in one place. And I guess the other thing that's kind of unique is we use a thing called UORB, which I guess is Mike Smith's invention. And what it is it's a pub sub model, but it's actually interfaced through the file system. So to create a publication, there's a set of wrappers in C++. You wouldn't recognize it as opening a file, but effectively it opens a file. And then a subscriber tries to open the same file, and now they're subscribed to the publication. And it's a shared memory kind of a system. It's interrupt safe, so publications can be done in interrupts. And it's kind of cool. It's really cool. Yesterday when the gentleman from Bosch was here and he was talking about their DDS and fast RTP, those are their intercommunication protocols. And what we have is we have a bridge that will take our UORB messages and convert them to fast RTP. So that's how we communicate with ROS. All the messaging that's done in the system as far as telemetry, sensor data, battery status is all published messages, and it's done in the drivers. So we have some very different driver architecture. It's funny because one of the key reasons for using NuttX was POSIX. And over time, what happened was UORB was developed, and we realized we need this publication that's fast. We can't put that in the operating system. It's too myopic from our standpoint, right? It's not something you would need in every driver, and it violates POSIX. So our drivers typically run outside the operating system and are publishing directly to these messages. And why we do this is because we can't tolerate the delays of going through the file system to acquire all the sensor data and then align it, and then republish it. It's just not possible. And the reason is good. Say what?
You need a sequencer.
We need it exactly. We need the sequencer from Sony. Yeah. So I mean, that was like I've been laying awake at night thinking, okay, we need to do an ASIC. We need to do something that does buses, gets everything time aligned, and then you can just grab it from a FIFO. And you walk in here, you know, or you fly over here and you sit down, and there it is. So it was really cool. Some ideas for the future. I guess Greg said the other day that fully nested interrupts isn't necessary as long as your interrupt latency is really low. And we do have high priority interrupts. But there are certain things that we need to know immediately and we'd be willing to interrupt.
So that's already been done in Tizen RT. You're welcome to backport it.
Okay. So licensing?
So I don't know what the license on Apache would be.
All patches are submitted under Apache, which means it's Apache.
Okay. So this, I guess, is another business
I have the
discussion.
same issue.
But actually the code comes from the NuttX website because I already published the design.
Once it's Apache, it does not come back out of Apache. So if it's patches against your code, well, I've had this issue with a commercial company that wanted to make some changes recently on I2C for IMXRT. And I've actually emailed them and say, I need you to send me these patches as clean patches with a statement saying that you're releasing them to me under BSD. You can't say, oh, I've made the changes in the Apache version, and then I can't diff them back out and put them back in. Leastways, I would feel uncomfortable about it. I don't know what the legal situation is, but I don't like talking to lawyers, so I try and avoid legal situations.
So this is an interesting case because I did the design and published the code on a wiki page. They implemented it and tested it.
Yeah, so
The whole thing becomes incredibly unpleasant when you've got multiple licenses. It's just getting to one set of licenses.
So if we were to look at going to Apache, I think we need a legal opinion about
yes.
those. And if we do that and we indemnify Greg, I don't know what the reason for not doing it would be. If we can go out and acquire code from these other repositories.
For me, the big benefit of going to Apache would be we can go blag everybody else's
Yeah,
code.
that's the thing. Right?
That's the only real benefit.
Okay, so that's the upside. The downside is we have to spend some money with an attorney to figure out what those clauses really mean in legal terms to protect Greg.
Yeah, my take on it at the moment is I don't think there's a risk, but I'm not a lawyer.
Yeah.
So we would need to get an opinion. There's a hand at the back.
Hi there, just to jump in, I don't know if this is helpful, but a friend of mine who's active in open source was talking to me about the Software Freedom Conservancy a while ago. And they seem to be an organization that hosts open source projects, and the dynamic is they try to take away all the kind of legal and other kind of non-dev stuff and help with that. They're a charitable organization, they've got Inkscape and a few other.
I like the sound of that.
Yeah, I don't know more than
probably
that.
very worthwhile to research that and
Yeah.
get the details on it because that might be a good avenue.
Greg and I have had a couple of reasonably heated conversations on this subject, and I think we both have the same opinion that we don't like talking to lawyers. My tolerance of them is probably a little higher than Greg's. So by all means communicate with me and we'll do it, keep it out of your hair for a while. And then
Sure,
see if there's anything in it.
These guys, I don't know them directly, they're friends of friends, but they're open source people, and I think they come from I think they're lawyers.
So
So
I'm
it's,
not sure I had about how people feel about changing the license. Basically, we'll be changing the license of possibly the whole code base to Apache.
Yeah, that's a good one.
We've done that in the past and people were opposed to it.
Well, can we take a show of hands?
Can I just ask, 'cause the trouble is, this is the blind leading the blind. All of us have got a limited understanding, I've probably got a little bit more understanding than most, but all of us have got a relatively limited understanding of what Apache is. Does anyone have concerns over Apache based on the concerns of their organization or personal feelings in their heart, besides the general uncertainty and of I'm changing something that isn't code and why the hell should I do this? So does anyone have any input from their organizations which would make them feel uncomfortable about it? So is there a show of hands for that? So I got a couple. You would have concerns from your point of view?
Yes. I would prefer keep BSD for commercial reasons.
What can you? I'm not putting you on the spot. I'm trying to understand.
Yeah, I'm also not a lawyer.
What are the concerns, the commercial concerns? Do you know?
It's because BSD allow us to use several different projects and integrate all together.
Yeah.
And Apache, there is a certain kind of limitation on that. Because as you said previously, what is Apache, stay Apache. You can't change it anymore.
It's not a copy left. It's not a copy left.
It isn't in any way viral. It doesn't spread to other files in your project. If you have a file which is Apache, it stays Apache, but it does not mean that files that happen to be too close to it also become Apache. And that doesn't exist in the way that, for example, it does with GPL. I don't want us to get into a whole discussion about
I think it's good.
The fact that you've got a concern
yeah.
is enough, because we have to address your concerns and run them to ground to either be able to argue, yeah, your concern is not valid, don't worry, you're safe, or your concern is valid. So I think what I'd like to do, and I'll pick this one up if people are comfortable, is I'll send a note to the mailing list and say, anyone that's got concerns about specifically Apache, because I think that's where we would go. Anyone that's got concerns, no matter how much legal input you've had or whether it's just that you're just nervous about it, email me privately so it doesn't amplify on the mailing list.
So we did that back in the old Yahoo group.
And I need to dig at that because you've sent me references to it.
Pretty much unanimously opposed to it. But I don't think people really understand Apache. I think that's one problem.
Well,
it's not understandable. It's not even.
That's exactly right.
Well, I always think that the problem, maybe the predecessor is one person needs to talk to a lawyer, get like a debrief, and then educate everybody on the truth behind switching from BSD to Apache. Because otherwise, I feel the same way.
The beauty of BSD is it's 2 paragraphs, 3 if you really get carried away.
And it's in plain English.
And it's in English. The problem with Apache is that you have to go get a bloody great license and go through it. Now, as far as I'm concerned, from the point of view of our organization, Apache gives me more protection. Because with BSD, I can give you some code, you can put it into your product, and 2 years later I can come along and sue you for using it because you're invalidating my patent. The only difference with Apache that matters in the real world is that if I give you code under Apache, I can't then sue you. So there is, from my point of view, no other difference that matters. But let's stop this and take it to the mailing list because...
I think there was one more concern. Let's get that voiced.
Yeah, there was one more concern.
Who raised their hand with a concern about using it? So Ben, what's your concern?
Well, my concern is I don't know enough to have a reasonable concern because I think the goals you have with BSD or Apache has to be clear. And what is your intention with NuttX in that kind of license? If you have a commercial, how do you say that? Concern.
Interest.
Interest. Yeah, thank you. You have a commercial interest. The concern about Apache because it's a copyleft license and a BSD license. There is a difference. So you have to have really clear what the differences are.
Yeah, I think everybody's in agreement on that.
I think...
Yeah, well, make them explicit.
Yeah. I think the different... Well, so a couple of things. One, let's collect everyone's concerns. Without... And I will collect them effectively anonymously. Okay, you're identified. Sorry about that. But in general, the concerns will be collected anonymously. And then we will find a lawyer to go and talk to actually get opinion. Say, okay, we're considering maybe-ish doing this. These are the concerns we see. Explain to us in plain English, and maybe the software conservancy is the right way forward. But let's do this carefully, because once it's done...
And it's more about understanding the consequence for us all.
Exactly.
In going to another license.
Yes.
And
So,
I'm certainly not a lawyer. My wife is.
That was my question. That was my next question. Is anybody married to a software attorney? Because could you go home tonight and just ask about this and let's get some, you know.
Yeah. Honey, do you fancy going out for dinner? By the way, there's something I want to do.
Exactly. Exactly.
You're already 2 days on that progress.
Could I just ask one more time, what is the motivation for changing the license?
From my perspective, stopping, cameras on, but stopping Zephyr, Tizen, all the rest of them being able to use our code, and we are not being able
Can't
to
use their code.
Oh, and
So-
there's an effort underway. Do you think that that's a threat? Or
It's not that it's a threat, it's already happened. There are repos that are parallel repos to NuttX that have been enhanced and not been able to be
Okay,
contributed
now I
back.
understand.
There's also
Thanks.
a lot of tools
I'm
that
a
are
newbie,
under-
so
Yeah,
And
thank
it's
you.
crazy.
Yeah, it's just wrong.
Yeah,
I
there's a
mean,
ton of tools that would be able to
oh, my camera.
I did this with the EHCI stuff just recently. I got an EHCI implementation which was under the Apache license with a bug in it, and I had to go back to the guy and say, I need you to submit this to me under BSD license, because otherwise I can't. I'm not going to. I'll work on it for free. I'm not going to charge you to work on it, but I need to be able to use the results of my labor.
Right,
and if I work on it under Apache, when I make the changes, they're Apache, and so you get it and I don't. That's crazy, because I want it to go into, and in the end, because they did it in the end, it took them too long, so in the meantime I'd already taken our LPC31 implementation and ported it to IMXRT, so before they could come back with a license released version that I could use. So that's how come we've got EHCI now for IMXRT, is because I implemented it when there's already a perfectly good implementation with one small bug in it. So this is the crazy situations you end up in when people have got different licenses.
But that is when you do great stuff in life. People are going to use it.
Yeah.
And I think that's a philosophy of NuttX in general. I think it's cool that platforms like Zephyr are using NuttX as a base. If they don't give it back, it's more. The people itself, and they have another reason to be in this life.
Well,
because they don't give it back.
But
so
I don't think they've done anything Machiavellian in this respect, at least. I don't think they've done anything Machiavellian. I don't think they've deliberately taken it in order to make sure it's a one-way valve or anything like that. That isn't what's happened. They just happen to have selected. They've got more commercial interest. They've got more lawyers at their disposal. And off the back of all their concerns, they have selected this license.
It's like Microsoft who did the same thing.
Well, Microsoft grabbed a heck of a lot of BSD license back in the day. That I believe the whole of the network stack was originally BSD 4.4.
And they become big, and we're all using it.
Yeah.
So I think, and that's the concern I have, is the motivation. I think the same motivation we are searching for. What is the real motivation to change the license? Because if we're afraid that people who use NuttX don't give back patches on BSD, maybe there are different ways to address that in a license form, other than going to Apache.
Well, anything we try and do on licensing where we change a word, it gets us into much more complexity and hot water, because we're not experts on this stuff. It will get much more complicated and involve many more lawyers than just selecting another license.
But if you take a picture of me,
well,
without asking me, you have a problem. So maybe we can go on different ways. That's what I'm saying.
Yeah.
In a legal way to apply it and address.
It's another one of these issues we're not going to resolve today.
No, but that's why you have to talk to people who can really address this problem and the motivation you have to change the license. Because you really made clear and explicit what the fear is of going to another license and the motivation you have.
I think
I personally have more fears because of the patent clause. So that's the legal issue we don't understand.
Yeah. So
when you take Apache code, you are granted the patent. You're granted use of the patent automatically. I can't grant you use of the patent. Okay? So it's a question. It's an issue. I wouldn't feel comfortable without.
Yeah. And my take on that is that you can only grant patents which you own.
Yeah.
So if you don't own any patents, knock yourself out. There's nothing you can do to me because I don't own the patents. But then Greg gets into a more complicated situation which is what happens is if it's a third-party patent, I'm owning the code or I'm copywriting the code, and then you use it. Exactly where do I?
So I grant you the patent that I don't own.
Yeah. How?
Yeah, but,
so,
we did the same with the professor I talked about with the foundation. We also did the same kind of way to protect his ownership in a way, because people also want to use his learning curve in everything we do in maybe now 15 years. So it's not about not willing to share. It's more that if people use it, they share back.
Yes.
Exactly.
Yeah.
So
I think the takeaway is that we have clarity that we need to go get clarity.
So you have the right approach. Find out what all the concerns are, and then address them.
Yeah, we'll take a couple of weeks.
Yeah.
Put something on the mailing list. Say, look, anonymously, tell me what your concerns are. They become Chatham House rules, so the sources are not identified. Then we go to a WEE's lawyer, and then we find a solution, or we find some proper advice. Last comment, and we move on.
At the end, it's probably not, of course the individual concern is valid, we should start there, but at the end of the day, what we've seen here as well is that the technology is used in real products, and there are companies integrating it, so there is certainly a business and commercial aspect kicking in, and then we end up with the lawyers of the big companies who are selling products with this technology inside. So yes, there is the individual thing, the community thing, but there is, I think, more and more we get the business aspect, and we have to contact the lawyers in all companies, and that there is no way out. So we should start that process in parallel.
I will take it on, because for me, I just want to be able to dip into these other code bases. That's what it boils down to. But we need to, we are, or I personally, am paranoid about licenses. I am really, really careful about what we do. And I expect everyone else to make contributions to operate in a similar fashion. Let's move on and get this finished, because
so back to the ideas for the future. We started the fully nested prioritized interrupts, and apparently if we change the license, we get that. So don't need to discuss it anymore. And I guess the other thing we've been looking at, and just the thing that, a takeaway from Zephyr that looked like it was of value, is the compile time device tree, to be able to change configurations in a human readable form for people that need to build a different version of a drone on a different controller that's pinned out differently. The value there is they edit a text file. They don't have to understand bits in GPIO. They just make a change in a text file. We recompile it, it generates the GPIO, defines, and we're off and running. So that's something that we're looking at. Whoops, went too far. So I was going to do a session on HeartFault debugging, but I was thinking about this, and I think it would be kind of interesting to see PX4 in action, and I asked Julian if he would set up what we call hardware in the loop testing. So we have a FMU V5 on the table here, not to be confused with the drone that's on the table. So I guess I consider myself very pragmatic. That's why the question about if anybody's married to a lawyer. When I have hardware that I need to transport around and have in the lab a lot, I will tape it down to a piece of cardboard so that it's laid out pretty well. And this is one of the prototypes that we did testing with originally. Actually, why don't you just take over the screen at this point? Yeah. So the setup is that there's a USB port on the FMU, and that's connected to the laptop. And the protocol that's being communicated between the laptop and the FMU is something called Mavlink. It was also designed by Lorenz, and it's used for communicating with autonomous vehicles. And so what you're seeing here is a couple of different pieces of software. On the right-hand side of the screen is QGC, which is Q ground control. And this is the application that you would be using if you were flying a drone it may be on a Android device, an iPhone, Apple device, on a PC. It runs everywhere. And I think what Julian did was he planned a mission.
Not yet.
Oh,
but
okay.
I will. Yeah.
Okay. So this is the drone taking off, and that's the drone that's on the table. It's actually, we're using all of the information and sensor data from the drone and running the hardware in the loop simulation of it. What's the visual tool? Is that Gazebo?
This is JMavSim.
Oh, JMavSim.
Yeah.
Okay, so there's different visualization tools. Actually, you know what, Julian, why don't you talk about this, because this is your area of expertise.
Where did you stop?
I stopped at what this is on the left-hand side of the screen.
Good.
I guess let me introduce Julian first. Julian is a member of PX4, and he works for Arterion.
Thanks. Okay, so basically, yeah, this piece of hardware here is doing what it would be doing flying normally with its real sensors, but so right now the sensors are faked by the simulator. So that's JMavSim, that's the thing on the left. So that just simulates the world and then fakes the sensors, sends the sensor data to the drone. The PX4, the flight controller, tries to do the best it can using those sensor values, as it always does, or tries to do a mission, as we can do that now. And then the thing it sends back is the actual motor commands, and the simulation then has to take those into account and do another step in the world. And so let me upload the mission from, this is Q ground control. Let's ignore that one for now and hope it worked. Let's see.
Well, it would be in alignment with demos that...
Exactly. Okay, let's do the following. I think the thing is that we already took off and we gave you the take-off waypoint, so I'm going to try to get rid of that guy, upload it again. Okay, that's better. And we'll...
Then we can push the changes, huh?
Yeah.
I need your help.
Question, just from my understanding, so you use the hardware, but the hardware you only run, so the PX4 stack runs on the processor?
Yeah.
The rest
So
of the peripherals
correct, yeah.
are not probably used, they are mimicked in the simulation?
they're mimicked in the simulation. The motor output is sent back to...
Yeah, so probably in other communities this is called processor in the loop and not hardware in the loop.
Okay,
because
sure.
You only basically run it on the software on the processor, right?
Yeah, that makes
Correct.
sense. Yeah.
Correct.
And are there no other hardware elements taken from the board?
No,
Okay.
no. So you are correct in your description.
Yeah, that makes sense. Yeah.
We also have software in the
Well, I
loop.
was a bit confused because where is the sensor data? But that is actually from the simulation,
Yeah.
not from the hardware.
Yeah.
So even if I would put hardware sensors on the box, it
Yeah.
will not affect the simulation, right? Because you were moving the box, but it didn't happen anything. So.
Right.
Yeah. Yeah, exactly. Yeah.
The thing is, if this was on a craft and we took the craft outside and we flew the mission, it'll do what it's doing here.
But we could take this a step further, you're right, where we
Take the sensor.
have a fake GPS, so we have an actual embedded thing that sends serial data as a GPS would, just in the same way. And then you could actually test more on what's running on the autopilot. Right now, that's not what we're doing. Yeah. But that would take it one step further. But
this, like logging, for example, would still be active, right? It would log, this mission gets logged to the SD card and other aspects of the hardware?
Depending on the generation and the available RAM, yes. Yeah.
Microphone's out again.
Oh, okay.
Oh, it died again?
So we did the mission.
Call for batteries?
And it's going to do an RTL at the end that I configured to. I also had this Must have been clunky with my hands, so here it went a bit far away. But now it's coming back. Questions?
Yeah, I guess, are there questions about what you're looking at?
How often is the sensor data refreshed? How often
Okay.
do you receive sensor data?
So this runs at 250 hertz. On the real thing, the sensors are read out faster, or on some boards it's faster, so 1 kilohertz, for instance.
In the newer architecture that we're working on, we're doing 32 kilohertz sampling of gyro data and publishing it at 1 kilohertz. So there's been some architectural changes in the driver code to support this, and there's been a lot of work. It'll probably be in the next release.
Yeah.
Do we read out the peripherals from the micro controller? You use the byte level buffer?
No, this is all going over a serial protocol that's being communicated, that's communicating all of the telemetry and motor information back.
So this is just serial over USB?
Yeah, we're not down at the low level in the operating system.
Okay. Are you guys done?
Yeah, I was going to do a demonstration about hard fault, how to debug a hard fault.
I would love to see that.
Would you like to see it? Is it worthwhile?
But do you mind if we do it this afternoon? So when we're doing the open hacking, maybe we do a split session and we do the hard fault stuff there, because
that'd be great. If people are interested, I mean, if you've already gone through it, it's not
it's
important.
the bane of my life, so better access to stuff to deal with that would be quite helpful. So, thank you very, very much.
You're very welcome.